Identify the central atom of the bond angle. In the HOC group of the glycinium cation, the oxygen O atom is the central atom, covalently bonded to one hydrogen H atom and one carbon C atom. Determine the number of electron domains on the oxygen atom. The oxygen atom involved in this single bonded configuration has two bonding pairs, one to H and one to C, and retains two non-bonding lone pairs of electrons. This gives the oxygen atom a total of 4 electron domains. Apply VSEPR theory to find the electron domain geometry. According to valence shell electron pair repulsion, VSEPR theory for electron domains will orient themselves in a roughly tetrahedral arrangement to minimize electrostatic repulsion. Estimate the bond angle based on molecular geometry. The ideal bond angle for a perfect tetrahedral geometry is 109.5 degrees. Because non-bonding lone pairs exert greater repulsive forces than bonding pairs, they compress the adjacent HOC bonding domains, pushing the angle to be slightly less than 109 degrees. Select the closest multiple choice option. Comparing the options, 105 degrees is close to 109 degrees and represents this slight compression from the ideal tetrahedral angle. This makes option C the correct answer. The correct answer is option C, 105 degrees.